See continuation here. Next result is log m base a is equal to log m base b divided by log a base b, or from this one only log m base b can be taken as what? Sending denominator to other side, we will get it as log m base a into log a base b. So now we need to prove this statement. See here, proof for this. To get it, I am going to take log m base b is equal to x, comma, log a base b is equal to y. From these two equations, we are having that b power x is equal to m, comma, b power y is equal to a. Okay. So from here, b is equal to m power 1 by x. Next, b is equal to a power 1 by y. Okay. So here we are eliminating b, then getting what? See here, in place of this first b, we can substitute this a power 1 by y. Then this becomes as m power 1 by x. Okay. Now you see here, taking log, what you can have? Log m power 1 by x base a, that becomes as 1 by y. From here, 1 by x into log m base a is equal to 1 by y we have. From this, we are having that log m base a is equal to x by y. So what is x? Initially we considered x as log m base b, y as log a base b. Log m base b divided by log a base b, that we'll have. From this, you see, you're equating this one and this fraction, then getting us what? Log m base a is equal to log m base b divided by log a base b. This one only we need to prove. So from this one only, what we can have? Log m base b can be taken as what? Sending denominator to other side, log a base b into log m base a. Now you see here, when these two numbers are same, we can take result as log m base b. So we have that one only, right? Log m base b. And you see here, when we have log m base a, we can take log m by log a with any base b. Okay. So this is a result. So generally we'll use this to get some problems. Okay. Next result you see here. Next result is a power log n base a, that is equal to n. So this one also we need to prove to get some problems. See here, we all know that log n base a is equal to log n base a. So both are equal only, right? Now we are removing this log so that these two numbers will interchanges. In that way we need to remember that already I said. Therefore what you have? A power log n base a is equal to n. Okay. So hence it has proved. So you see here, when these two numbers are same, here a is there, here a is there. Now n becomes as result. This n becomes as result. For example, you see here, 2 power log 10 base 2, that becomes as 10. Okay. So anyway, we need to do next one. Next result that we need to prove is log n base a power q is equal to 1 by q log n base a. So this one we need to prove. See here, proof for it. You take log n base a is equal to some x. So from here what you have? A power x is equal to n. Okay. So this will implies as what? a is equal to n power 1 by x. Now taking power q on both sides, a power q is equal to n power q by x. N power q by x. We have taken power q on both sides. So the same thing can be taken as a power q whole power 1 is equal to n power q by x. Now taking log. Then what you can have, you see here, these two numbers will interchanges. Power 1 here and n power q by x. This whole thing. So both are going to interchange. Then what you can have, log n power q by x, okay, base a power q, base a power q, right? So you see here is equal to what? 1. From here this q by x we can take here, q by x log n base a power q is equal to what? 1. From this log n a power q, log n a power q is equal to 1 by q x, right? 1 by q into what is x? So x is nothing but log n base a, log n base a. So from all these you see here, equating first one and this last one, then getting us what? Log n base a power q is equal to 1 by q log n base a. This one only we need to prove. Okay, so anyway that has proved. Next we need to discuss about increasing and decreasing functions. So log x base a is an increasing function when base is greater than 1, and log x base a is a decreasing function when base is from 0 to 1. Okay, so before that we need to discuss about increasing and decreasing functions. Okay, see here, let y is equal to f of x is an increasing function, an increasing function. Okay, so see here, now we are going to discuss about this increasing function, and it is continuous and differentiable function. Suppose, see here, this is y axis and this is x axis. Okay, on x axis we will give x values and on y axis we will give y values in general. Anyway, you know that. Suppose the graph of y is equal to f of x will be like this. So see here, this is graph of y is equal to f of x. Here I am giving some x values. See here, this is x1 and this is x2. Okay, when we are substituting x1 value of y, we are going to get on y axis. What is value of y? On substituting x value as x1, f of x1, right? F of x1. And on substituting x2, we are going to get f of x2. So see here x1 less than x2 and f of x1 less than x2, that we are getting, right? So therefore from above graph what you can have, x1 less than x2 implying as what? X1 less than x2 implying f of x1 less than f of x2. Okay, so that means what? On taking f on both sides, see here, on taking f on both sides, the same inequality we are getting. Okay, the same inequality we are getting, right, on taking f on both sides. In reverse, you think, on removing this f, on removing this f, then what we are getting? The same inequality we are getting, right? So for increasing functions, what we can say, on applying the function, on applying increasing function or on removing increasing function, inequalities does not changes. That I want to say. So both sides implies, you can say. So this is all when f is an increasing function. Okay, now you see about a decreasing function. Let y is equal to f of x is a decreasing function. Is a decreasing function. See here. Now we are going to discuss about this decreasing function. Let it be continuous and differentiable. This is y-axis, okay, and this is x-axis. Decreasing functions means you see here on increasing values of x, y values will decreases, so that you can have graph like this. You may have graph like this. You see here, this is x1, this is x2. x1 less than x2 here. What we are getting on y-axis? We are getting f of x1 here, and here f of x2. See here, f of x1 is more than f of x1 is more than f of x2 here. Okay, so therefore here what we can say, x1 less than x2 implying as what? F of x1 will be more than f of x2 we are getting. That means on taking f on both sides, that means on taking increasing function on both sides, inequalities will changes. Okay, and you see here on removing f on both sides, then also inequalities will changes, right? So both sides implies, you can say. Okay, so on applying f or on removing f, inequalities will changes. Okay, this result you should know actually. Okay, now we are going to discuss about logarithmic function. See here, let y is equal to log x base a. Here base is greater than 1, suppose. Okay, now we are going to take the graph of this function when base is greater than 1. See here, a greater than 1 means, suppose a value I am taking as 10. Okay, then y value becomes as what? Then y value becomes as what? See here, log x base we are taking as what? 10. Okay, now applying x value as 10, then respective y value is what? Respective y value is log 10 base 10. Why in place of x I am applying 10 here? Log 10 base 10 value is what? 1. So therefore on taking 10 as x value, we are getting y value as 1. So this implies as what? 10 comma 1 is a point on the curve, right? 10 comma 1 is a point on the curve. Next, x is equal to 100 you take. Then what about y value? Log of 100 base 10. This can be taken as what? Log 10 square base 10. The same thing becomes as 2 log 10 base 10. 2 into log 10 base 10 value is what? 1. So we are going to get it as 2. So therefore on taking x value as 100, we are getting 2. Taking x value as 100, we are getting 2. Okay, so you see here, based on these 2 points on the curve y is equal to log x base a, we are going to take its graph. You see here, before that I want to take one more point. When x is equal to 1, what about y value? Log 1 base 10. Log 1 value is what? 0. Log 1 value is what? 0. On taking x is equal to 1, y value is what? 0. So therefore 1 comma 0 is also a point on the curve. Now I am going to take its graph. These are values of x and these are values of y. Y value is nothing but here log x base a values only. right, where a is 10 that we have considered here. Now you see this point 1 comma 0. 1 comma 0 point will be here. Okay, and on x-axis you are having 10 here and you are having 100 here, right? Here 10 you have, here 100 you have. And on y-axis you see here, here 1 will be there and here 2 will be there, suppose. Okay, so I am giving first point, that is what 1 comma 0 I have given. Next 10 comma 1 I am giving, you see here 10 comma 1, 10 comma 1 point will be here, right? So point will be here. Next 100 comma 2, 100 comma 2, that point will be here, right? So now you see here, on joining those all points you may have graph like this. Okay, now you see here, this is an increasing function, is an increasing function. So what is that function? Y is equal to log x base a. So is an increasing function all when base greater than 1. Okay, so see here, as that is increasing function, suppose x1 less than x2 implies as what? Here this logarithmic function is increasing function, right? If we take log with the base, suppose more than 1, let it be 10 or something like that, or you take a only, a is greater than 1, suppose, as that is increasing function, inequalities does not change. So that's why I am taking same inequality. Okay, log x1 base a, log x2 base a, x2 base a. Okay, so why this inequality didn't change it? See here log x base a is an increasing function, that's why it hasn't changed. So you can have both sides implies. Now you see here logarithmic function when base greater than, when base less than 1 and greater than 0. See here, let y is equal to log x base a. Okay, here base is from 0 to 1, suppose, that means base less than 1. In that way I am taking. Now we are going to take its graph. Now we are going to take its graph. You see here, you take a value as, for example, you take a value as 0.1, a value as 0.1. Then y becomes as what? Y is equal to log x base 0.1. y in place of a we considered 0.1. It is less than 1 only, right? That's why I have considered to get its graph. Okay, so see here, x is equal to 1 I am giving. Then respective y value is what? Y is equal to, see here, log 1 base 0.1. You know log 1 value as 0. And x is equal to, see here, I am going to give 0.1, suppose. 0.1 or some 10 you give. 10. Then y is equal to what? Log 10 base 0.1. So 10 can be taken as 0.1 whole power minus 1 and base here is 0.1 only. This can be taken as minus log 0.1 base 0.1, that is what? 1 only, minus 1. Okay, so see here, from this what we can say, when you are taking x value as 10, y becomes as minus 1. X value as 10, y becomes as minus 1. And from here you see, when we are taking x value as 1, y becoming as 0. 1 comma 0 is a point on the curve. Okay, so based on these 2 points I am going to take its graph. See here, this is y-axis and this is x-axis. Here you will have 0, okay, and here you will have 1 and here you will have 10. right? And on y-axis also I'm going to give some points. You see here, this is -1 and this is 0. Okay, so what is first point? 1 comma 0. This is 1 comma 0, and next one is what? 10 comma -1. 10 comma -1 point will be here, right? So joining all those points, you can have graph like this. You can have graph like this. Okay, see here, this is graph of y is equal to log x base a when base less than 1. So when base less than 1, you got it as a decreasing function. You see, this is a decreasing function. Which function is it? That is y is equal to log x base a. We got it as a decreasing function when base is less than 1. So when base less than 1, log x base a is a decreasing function. Okay, when base greater than 1, so it is an increasing function. So therefore here what we can say, when x1 less than x2, already I said for decreasing functions, on applying decreasing functions, so log with the base a here is a decreasing function, right? So that's why inequality will changes. Here less than symbol you have, now here I am going to get greater than symbol. Why? Here log x base a is decreasing function that we are applying here. Okay, log with base a we are applying for those variables x1 and x2. Okay, so see here base is less than 1. When base less than 1, log x base a is decreasing function, so that's why inequality has changed. Okay, so both sides implies you can write. So this is all about graphs of logarithmic function. Now we are going to discuss a problem based on this. See here, based on this we are going to discuss a problem, that is, if log of x minus 1 base 0.3 is less than log of x minus 1 base 0.09. Okay, then x lies in the interval, then x lies in the interval, then x lies in the interval. Okay, so you see first option is 2 to infinity, and second option is -2 comma -1, -2 to -1, and third option is 1 comma 2, and fourth option is none of these. Okay, so see here, we are going to discuss this. See solution for it. Anyway, I am going to take given inequality. What is given inequality here? Log of x minus 1 base 0.3 less than log of x minus 1 base 0.09. Okay, so this will implies as what? Log of x minus 1 base 0.3 less than log of x minus 1. 0.09 can be taken as what? 0.3 whole square, right? So from here you see log of x minus 1 base 0.3 is less than, now you see this 2 can be taken like this. So 1 by 2 of log of x minus 1 base 0.3. So using the result, that is already we have discussed, log x base a power q, that can be taken as what? 1 by q. So that's why I have taken here 1 by 2. Okay, log x base a. Using this result I have taken this one already we proved it. So this implies as what? Log x minus 1 base 0.3, right? less than. Now this 1 by 2 can be taken as power for this x minus 1, and here base is 0.3. So this is using the result, that is n log x base a can be taken as what? Log x power n base a. So this one also we proved. Okay, so now you see here, this logarithmic function, this is logarithmic function base 0.3, logarithmic function base 0.3. So base is less than 1. When base less than 1, on removing that function, inequality will changes. When base less than 1, that logarithmic function is a decreasing function. On removing that decreasing function, inequalities will changes. Now we are going to change the inequalities. You see here, then what you can have? X minus 1. Okay, inequality should change, right? So that's why I am giving this greater than symbol, less than symbol to greater than symbol I am giving. X minus 1 whole square you have, right? Whole power 1 by 2 actually. So you see here whole power 1 by 2 is there. X minus 1 should be a positive number. Okay, so within log you should have positive numbers only. Initially only I have given, okay, at the starting of logarithms only I have given that. You see here, suppose log x base a, x should be more than 0 I have given, a also should be more than 0, and a should not be equal to 1. So these things I have given. So that means whatever the thing you have in logarithmic function, that should be greater than 0. Okay, so you see here x minus 1 is there in the logarithmic function. That is why you should have that x minus 1 should be more than 0. That is only I have written here, right? Now taking square on both sides, x minus 1 whole square greater than x minus 1, right? Now expanding this, x square minus 2x plus 1 greater than x minus 1. See, from this x square minus 3x plus 2 you will have greater than 0. Okay, so this thing can be taken as what? Doing factorization, x square minus 2x minus x, in that way you can write. Okay, you take x as common, you will have x minus 2. You take minus as common, you will have x minus 2 greater than 0. Here x minus 2 is there, here also x minus 2 is there. That can be taken as common. Then getting us what? X minus 1 more than 0. Okay, now taking real line, you will have 1 here, you will have 2 here. Okay, first we are applying these values in place of x, then getting us what? For example, you take a number less than 1, that is minus 10. You apply in this, then getting what? 10 minus 2 into 10 minus 1 greater than 0. See here, 8 into what we are getting? 9 greater than 0. 72 greater than 0. This is correct statement only, so all these values can be taken. Okay, now you apply these values from 1 to 2. From 1 to 2, you see here I am applying, for example, 1.5 in this statement. Then getting what? 1.5 minus 2 into 1.5 minus 1 greater than 0. So this is what? Minus 0.5, and here 0.5. So minus 0.5, 0.5 will gives us what? Minus 0.25 I think, right? This is greater than 0. So you see here minus 0.25 is less than 0, not greater than 0. So that's why this is incorrect statement. So you can't take these values as x values. Okay, so in the same way you need to check for these values also by taking some number. You take 10 and you apply in this, then getting what? 10 minus 2 into 10 minus 1 greater than 0. 10 minus 2 is what? 8. 10 minus 1 is what? 9. greater than 0. Actually, you see here you have to take negative sign, right? Then getting us what? Minus 12 into minus 11 greater than 0. So 12 into 11 greater than 0. Correct statement only. So that's why anyway you can take these values. Okay, here what we are getting, 72 greater than 0. This is correct statement, so you can take these values. Okay, so finally what we are going to get, x belongs to the values from minus infinity to 1 union 2 to infinity. Minus infinity to 1. So you see here exactly 1 can't be taken. So that's why you take open bracket. If you are taking exactly 1 here, 1 will get cancels. You will get it as 0. But 0 is not there. Greater than 0 you want. Greater than 0 you want. So that's why exactly 1 can't be given in place of x. So that's why given open bracket. Open bracket means you can't take x value as 1 exactly. Union. Next, these values. What are these values? 2 to infinity. Similarly, 2 also can't be given in place of x. So that's why given open bracket to 2. That means exactly 2 you should not take. Anyway, 2 to infinity you have. Okay, these are values of x. But you see here, based on this condition, based on this, what is that? X minus 1 is greater than 0. That means x should be more than 1. More than 1 means, so see here, these all values are less than 1. These all values are more than 1. So that's why these values can be taken. Which values? 2 to infinity values can be taken. So finally, x belongs to 2 to infinity. These are values of x. So 2 to infinity you are having in first option. So therefore first option is correct one. Okay. So this is a problem based on increasing or decreasing functions. Okay. Now you see one more problem is there. See, that is, if x power log x base 5 greater than 5, then x belongs to, x is there in which interval, that we need to find. Okay, so this question we need to solve. See solution for it. Anyway, given thing I am taking, what is that? X log x base 5 greater than 5. Okay, now we are taking log with base 5 on both sides. Log with base 5. Log with base 5. 5 is more than 1, so this is an increasing function. On taking this increasing function, you inequalities does not changes. As I said, for increasing functions, inequalities does not changes. Here also inequalities does not changes. We are taking log with base 5 on both sides. So then what you have here, x power log x base 5, and here what you have, 5. Okay, so see here, this number can be taken here, log with log x base 5. Again what you have, log x base 5 greater than, log 5 base 5 value is what, 1 only. So here what you can have, log x base 5 whole square more than 1, right? From this, log x base 5 whole square minus 1 you can write greater than 0. Okay, now in place of log x base 5 I am going to take y. Okay, y square minus 1 can be taken as 1 square greater than 0. Now you see here, this can be taken as y plus 1 into y minus 1, as that is in the form of a square minus b square. y plus 1 can be taken as minus of minus 1, and here y minus 1 you have greater than 0. Okay, so now you see here again you have to take number line. Here minus 1 is there and here plus 1 is there. Okay, you have to apply any of these values. We are going to get correct statement or incorrect statement, that we need to check. For example, I am going to take minus 10 and applying in this inequality. Then getting what? Minus 10 plus 1 minus 10 minus 1 greater than 0. Here minus 9 you have and minus 11 you have greater than 0. This is what? Plus 99 greater than 0. Correct statement only. So you can take these values. And check for these values also, you can't take these values, and check for these values also, you can take these values. Okay, so what we can take? Y can be taken from minus infinity to minus 1 union, and y can be taken from 1 to infinity. Okay, now what is y? Y is nothing but what? So you see here y is nothing but log x base 5. Y is nothing but log x base 5 here, minus infinity less than log x base 5 less than minus 1 union 1 less than y is nothing but log x base 5 less than infinity. Okay, now you see here this infinity can be taken as what? So anyways, taking this log x base 5 and minus 1 can be taken as what? Log of 5 power minus 1 base 5. Okay, union 1 can be taken as log 5 base 5 less than log x base 5. So see from this what you have, we are removing log with base 5 on both sides. Base 5 is more than 1, so that is an increasing function. On removing increasing functions, inequalities will changes, that you know, right? X less than 1 by 5 or 5 power minus 1 only you write. Inequalities will not changes. Why? That is increasing function, right? So 5 power minus 1 only you write. X should be less than 5 power minus 1. But you see here, X is, see here, X is in a logarithmic function, compulsory that should be a positive number. Okay, compulsory that should be a positive number, so it should be more than 0. Union, you see here log 5 base 5 value is what? 1, not like that. Here you remove this function log with base 5. Base is more than 1. Base here is 5 more than 1. So that function is increasing function. On removing those increasing functions, inequalities does not changes, that you know. So 5 less than x you have. Less than x, and x you can have up to infinity, you can say. Okay. So 0 less than x less than 1 by 5 union 5 less than x less than infinity. So therefore finally x belongs to 0 to 1 by 5 union 5 to infinity. Okay, so this is the interval for x to satisfy given condition. I want to give you one more result, that log m base a can be taken as 1 by log a base m. So I want to prove this result also. See here. See here. As we know that log m base a is equal to log m base b divided by log a base b. This one already we proved. previously. See here, we are going to substitute b is equal to, see here, we are going to substitute m is equal to b on both sides. Okay, m is equal to b on both sides, then getting us what? Or b is equal to m, we are substituting. See here, we are substituting that b is equal to m on both sides, then getting us what? Log m base a is equal to log, in place of b I am writing m on both sides. Okay, so log a, in place of b we are writing m on both sides, right? See, this is equal to log m base m is what? 1 divided by log a base m. So from this you see here, log m base a can be taken as 1 by log a base m. Okay, so you see here, when we are taking reciprocal, then these two numbers will interchanges. Okay, for example, you see here log 5 base 2, that can be taken as what? 1 divided by, you interchange these two numbers, then getting what? Log 2 base 5. Okay, by using the above result. Okay, so you see here, we are going to discuss a problem, that is, if y is equal to a power 1 by 1 minus log x base a, comma z is equal to a power 1 by 1 minus log y base a, log y base a, and x is equal to a power k we have. Okay, then we need to get the value of k. Then we need to get the value of k here. So see, this is question. Okay, we need to get it. See, anyway, I am going to take log a on both sides for this equation. Okay, then getting what? Both sides log with base a we are taking, then log y base a is equal to log with base a we are taking on both sides, then what you have? A power 1 by 1 minus log x base a you have, right? So in this equation also we are going to take log with base a on both sides, log with base a on both sides. So what you have? 1 by 1 minus log y base a you have. Okay, in next equation also log with base a we are taking. Log x base a is equal to what? Log a power k base a. Okay, so see, from this what you have? Log y base a is equal to, this whole number can be taken here, 1 by 1 minus log x base a into log a base a is what? 1 only, or log a base a you write here, that becomes as 1 only. Now you see here, log z base a is equal to, this whole number can come here, 1 by 1 minus log y base a, right, into log a base a value is what? 1 only. Okay, now you see here, log x base a is equal to what? K can come here, into log a base a value is what? 1. From this equation k can be taken as log x base a, or log x base a can be taken as what? K. Okay, see here, log y base a is equal to 1 by 1 minus log x base a can be taken as what? From this k. So I am writing k here anyway, into 1 is there. log z base a is equal to what? 1 by 1 minus log y base a into 1. Okay, so we need to get the value of k, that's it. So it will implies as what? 1 minus k is equal to 1 by log y base a. Okay, next 1 minus log y base a is equal to what? 1 by log z base a. Okay, now we need to get the value of k. From this equation, k is equal to what? K is equal to 1 minus log y base a. Okay, see here, and from here what you can have? Log y base a is equal to 1 minus 1 by log z base a. Okay, this is equal to 1 minus 1 by, in place of log y base a, what you can write? In place of log y base a, what you can write? This one can be written. Why? That is log y base a only. 1 minus 1 by log z base a. Okay, 1 minus 1 by log z base a. Now doing LCM, then 1 minus 1 by log z base a, okay, minus 1 whole divided by 1 minus 1 by log z base a. Okay, see here, 1 both will get cancels, then what you can have? Minus 1 by log z base a, and in denominator what you can have? You see here, and in denominator you are having that log z base a minus 1 whole divided by log z base a. Now log z base a, log z base a both will get cancels. Therefore, that is equal to what? Minus 1 by log z base a minus 1. Okay, so this is equal to 1 by 1 minus log z base a. Okay, so this is value of what? That is value of k. So finally we need to get the value of k. We got it in terms of z and a. So I need to check with options. Yes, that is correct one only. Okay, thank you everyone.